Hello everyone, this is the first lesson recording for October 6, 2020. Let's start off with some announcements. You took a quiz last lesson, so if you are absent or you're missing, then you need to contact me as soon as possible. Now, if you took the test or quiz, but you're not happy with the results, then you should be considering taking a retake. Okay, so far I've had about 8 students who have taken the retake on quiz number 3, and they have all scored 87.5% or 100%, and this could be you too. And whatever score you get on the retake, you keep, okay, or whichever is higher. Okay, so and this is a great way to not only improve your grade but your learning. Remember, we are going to be testing you on the same material on the unit test, and unit test is going to have much bigger proportion of your overall grade. So you actually need to do better on the unit test, as well as there are no retakes on the unit test. So please contact me as soon as possible to arrange a time to go over the quiz together, and then you can take the retake the following day. Some of you are asking, oh, I don't want to take the retake because I might actually do worse on the retake. Well, if that happens, and it usually never happens unless you do not go through the quiz with me, then the original or the higher score will be kept. So you really have nothing to lose, okay? Your score is not going to go down. It can only go up from the retake. What are we doing today? We are going to review the equivalent fractions, because we are going to be working on that a lot with slopes. And then we're going to go dig deeper into slopes and y-intercepts. So to begin, let's see if you can compare these two numbers, two fractions, 3 over 8 and 6 over 16. Which is bigger, which is smaller, which is equal to? Okay, which is true? Well, how do we do that? It's difficult to compare when the denominator is not the same, right? But can we do so? Well, that's where the equivalent fraction comes in. So let's look at this mathematically, okay? So when you have 3 over 8 and 6 over 16, now we can multiply any number by 1 and we're not changing anything. So we can multiply any number by 1. So we have to consider, okay, how can I make 8 into 16? Well, if I multiply this 8 by 2, I can get to 2. Let me just, okay, and if I'm multiplying the denominator by 2, I need to multiply the numerator by 2 as well, because 2 over 2, what is 2 divided by 2? That's just 1. This is really the same as multiplying my giant 1. Remember our giant 1? Giant 1s are our friend. Okay, so then if I multiply 2 by 8, that just becomes 16, and 2 by 3 is 6. Remember, when you're multiplying fractions, you always multiply across, like so, and multiply across like that. Okay, so this actually turns out 6 over 16 is same as, or 3 over 8 is same as 6 over 16. So they are actually equal. Okay, so let's look at this more visually. Okay, so when you think about 3 over 8, that means that, oops, 3 over 8 means this pizza is divided into 8 parts, and we have 3 of the 8 parts. 1, 2, 3 parts. We have this much of pizza remaining. Okay, 6 out of 16 just means when the pizza is divided into 16 parts, and that's how many we have here, we have 6 of those pizzas. So 1, 2, 3, 4, 5, 6. 6 pieces of those little pieces, and they are indeed same amount of pizza remaining. Okay, so we can see visually that they are the same, and we can see mathematically that they are equivalent. Okay. All right, so then I want you to tell me in private chat which is true. Is comparing 2/7 and 5/14, which is bigger, which is smaller, which is equal to? Is 3/7 bigger than 5/14, or is 3/7 smaller than 5/14, or is 3/7 equal to 5/14? I want you to tell me in private chat now. Okay, so, well, let's think about this. Visually, 3/7 means one whole is divided into 7 parts, and from here I have 3 of the parts. 1, 2, 3 parts. 3 of the parts. Okay? But then what does 5/14 mean? Okay? It's not divided into 5/14. Oops. Okay, to figure out what 5/14 looks like, I need to divide this into 14 parts. That means I have 7 parts. That's not enough. I need 14 parts. That means I can divide each of these parts into halves. Okay, like so. Okay, and that means I have 5 of the 14 parts. So 1, 2, 3, 4, 5. So I have this much remaining. This is how much I have compared to this. Okay, if I was to divide this into 14 parts, I actually have 1, 2, 3, 4, 5, 6. 6 of the 14th part. If I was to do the same thing with all of these as well, divide each of 1. Okay, so now that is same as multiplying this. Oops, multiplying this by 2/2, because this is my giant one, and that just becomes 6. 2 times 3 is 6/2 times 7 is 14. So this, 3/7 is same as 6/14, and comparing this to 5/14, I know that this is bigger. Okay? Alright, so equivalent fraction. What is equivalent fraction? Fractions are two fractions that represent the same quantity. So here you have a whole divided into 5 parts, and of that we have 3 parts shaded. That means we have 3/5. Okay, so this is same as if I divided into not just 5 parts, but if I divided each one of the parts into half, then I actually have 10 different parts, and out of the 10 different parts I have 6 of them. Okay, and which is same as multiplying 3/5 by 2/2, and this is my giant one again. Okay, I am always allowed to multiply anything. I'm always allowed to multiply anything by 1, my giant one. Okay, and that is why I can multiply the top by 2 and the bottom by 2, and that gives me my equivalent fraction, which is 6/10. So 3/5 and 6/10, they are equivalent, and you can see it visually as well. Okay, we say they are equivalent. So please take notes on this now. Please pause the video and take notes on this. This is hidden by. Oops. Okay. All right, then let's continue. All right, so this time I want you to try to figure out what should I multiply to get this denominator, the bottom number, to become 18. What am I multiplying? Whatever I'm multiplying at the bottom, I need to do the same. So can you figure out what the square boxes are and what the question marks are? Okay, and you're taking notes on this too. Okay, I'm going to assume that you've had a chance. Okay, so 6 times what is 18? 6 times 3 is 18. So what if I'm multiplying the bottom number by 3, then I need to multiply the top number by 3 because that's my giant one. And so then 6 times 3 is 18. 2 times 3 is 6. Okay, so 2 6 is same as 6 18. They're equivalent. Okay, now this time we are told, okay, we are missing some numbers at the top here. Okay, so we are starting with 20 over 28. And we know that that is same as 7 times what? 7 times what is 28? 7 times 4 is 28. And if I'm multiplying the bottom number by 4, then I need to be multiplying the top number, the numerator, by 4 as well. And what number times 4 is 20? This has to be 5, doesn't it? 5. So that question mark has to be 5. Okay, so that means 5/7 is same as 20 over 28. Another way of looking at this is, can you think of a number that is divisible to both 20 and 28? It's actually 4, isn't it? 4 times 5 is 20, 4 times 7 is 28. So I could be thinking about dividing the top by 4 and then dividing bottom by 4. Just like we can multiply by giant 1, you can divide by giant 1 as well. Okay, because anything divided by 1 is just that, anything. Okay, so 20 divided by 4 is 5, 28 divided by 4 is 7. So they are equivalent fraction. Okay, now we're looking at 15 over 24. Okay, so now we have to be thinking, okay, what number, is there a number that is divisible by both 15 and 24? Well, 3. Or we also know that 5 times 3 is 15. Okay, and then if you're multiplying the top number by 3, then we need to be multiplying the same thing by 3. What number times 3 is 24? This has to be 8. Okay, that means this giant 1 cancels out and you are left with 5 over 8. Another way you could have thought of was divide this by 3 and divide this by 3, and you would have gotten 5/8 as well. Okay, now what about this one? 12, 6, something, 5. What did I multiply to 6 to get to 12? I multiplied by 2. And so I need to multiply the bottom number, denominator, by 2. So this is 10. Okay? Okay. Alright, so now at this point, we're going to do some exercises just visually, looking at these different graphs. Okay? Which line is the steepest? Okay, just tell me, what do you understand about the word steep, and which is the steepest? Well, I hope you're telling me this one, A and F. Okay, and it turns out that these are the slopes. Okay, the slope was 2 here, and slope here was -2, compared to slope of 0.5 and 1 and -0.5 and -1. So this helps me to come to take some notes here. So what is slope? Slope is a number that represents steepness and direction of a line. And the steeper the line, the larger the slope's absolute value. Absolute value means we don't really care whether it's positive or negative. We just care about the number itself. Okay? Alright, and the flatter the line, the smaller the slope's absolute value. And if the line is increasing from left to right, the slope is positive. And if the line is decreasing from left to right, the slope is negative. Okay? And slope tells us the rate of change in situations as well. Okay, so I do want you to take this down. And I'm going to continue with the next lesson recording.